Hello, welcome back to our coverage from AWS reInvent 2018. We're live from the Sands Expo in Las Vegas at the Amazon Web Services Customer and Partner Conference, AWS reInvent. And this is another one of our deep dives into recently launched AWS services, and I'm joined by Steve, Prashant, and Rudy on the stream for you right now. As usual, if you have questions, you could submit those to us via Twitch chat, and we will answer them live on the stream, or rather, get our expert guests to answer them live on the stream. And in common with most of our segments today, the first thing I want to do is just ask our experts to introduce themselves. So can you tell us a little bit about who you are and what you do here at Amazon Web Services?
Absolutely. I'm Steve Mueller, Software Development Manager, Amazon Protective Services, and I am responsible for delivering data to help our customers make a better choice on which shuttle to take, and which transportation method they take at all.
My name is Prashant Prahlad. I run product management for our AWS IoT Edge services.
Okay, Rudy?
Rudy Chetty. I'm a solutions architect for AWS, and I do everything IoT as well.
Awesome. Now you mentioned edge computing there, Prashant. So the first thing I want to ask you is if you can explain for our viewers precisely what edge computing is and why it's becoming increasingly important to our customers.
Sure. Edge computing has many definitions. How we think about edge is we try and process data close to where it's created. So we build services and products that help us process this data close to where it's created in edge devices and so on.
Okay, great. Two of the services that we often hear about from AWS when we're talking about edge computing are AWS IoT Greengrass and something else called FreeRTOS, which was announced at AWS reInvent last year. Can you, Amazon FreeRTOS that is, can you talk a little bit about what those two things are and how they're different?
Sure, so the two products you mentioned, let's start with Greengrass. So Greengrass is AWS IoT Greengrass. It's packaged software that runs on devices.
Okay.
So if you have a device that can run Linux, for example, Greengrass will run on that as a runtime, and then it helps you have the same development environment that you had in the cloud on those devices. So you can build your applications in the cloud, run them on these devices using Greengrass. FreeRTOS is really interesting. FreeRTOS is a pretty popular real-time operating system that has existed for over 15 years. And what we've done with Amazon FreeRTOS is enabled microcontrollers, so devices like your light switches or light bulbs and small little things like thermostats, allow these devices to run FreeRTOS and have Amazon libraries that allow them to connect back to the cloud and send information to AWS IoT.
And those microcontroller devices are much smaller and lower power than the kind of devices that run Greengrass, correct?
That's right. So microcontrollers have, let's say, kilobytes of memory on them, so they're very, very constrained. And Greengrass, as an example, runs on devices with megabytes of memory, so 128 plus.
Yeah. Okay, great. And what have you announced this week at AWS reInvent? What's new in the edge computing area from AWS this week?
Oh, many things. A lot of announcements, a lot of interesting stuff related to Greengrass and FreeRTOS. Let's start with Greengrass. With Greengrass, we announced several security features, several applications. Of the security features, the one that we're going to look into a lot more deeper is called the hardware secure element integration or hardware security integration that allows you to encrypt data and store the private key that's used to encrypt that data on the secure element in the device.
Oh,
so we work with...
Is it an actual chip that you say I'm storing it on?
Yeah, it's called a secure element that's available on several devices. It's called TPM with Intel chips. It's called secure element and others. So we encrypt that data and store the private key in the secure element. What that means is that the only way you can get to that data is if you tamper the hardware, which is very difficult. So that's one feature. The other one we announced was Secrets Manager. Secrets Manager allows you to create secrets in the cloud and then seamlessly use those secrets on Greengrass-enabled devices. So what that helps you do is you create a Lambda function or an application in the cloud, and you use those secrets in the cloud, and then seamlessly when you're running the same Lambda applications on Greengrass, those secrets are available to you with the same policies that you put in place. Cool. The third element we launched was something called Greengrass Connectors. So Greengrass Connectors allows you to get started with Greengrass with pre-built applications that we're providing. Examples of these are, for example, sending logs and CloudWatch metrics all the way to the cloud directly from Greengrass without having to write any code. So There are 10 such examples we put out there for customers to start using without having to be experts in writing Lambda functions.
Sure, sure.
And the last one, which is probably pretty significant for us, is improvements to machine learning on greengrass devices. So that one actually allows you to create machine learning models, build and train them in the cloud using SageMaker, and then compile those models down to bytes that are run directly on hardware. And what that lets you do is make those models framework agnostic, which means the models can run on devices that are much smaller than previously. They run with no loss in accuracy, and they're far more performant.
Wow. Okay, this could be a little bit abstract to customers that are watching the stream, so can you talk a little bit about use cases? What kind of real-world applications might customers have for some of these services and features that we've recently announced? How do they get used by customers?
Yeah, a great example is cameras. Camera devices, for example, they are capable, now more capable than ever before, of running quite beefy workloads. They can now run these, for example, machine learning models on them to do image classification, anomaly detection, for example. And because these models are much smaller, you can run them on a large array of devices, right? So even smaller cameras, not just the beefy ones, can run these machine learning models. The security elements allow you to connect devices to any SaaS provider you wanted. So if you wanted to send data to Splunk, for example, you can do that using some of these connectors. So there are a lot of use cases. We're very excited about some of these that have been enabled through these launches.
Great. So I want to turn it over to Steve now. And Steve, I think you've got a demo to talk us through and a little bit of interesting looking hardware on the front of the desk there. So I'll turn it over to you. What do you have to show us today, Steve?
Are you going to show off your hardware?
I can.
Sweet.
So we always love to bring props. What I want to first focus on is what problem are we trying to solve? And so last year, for the first time ever, we announced, or we launched transportation as a service, right? You could take a shuttle, you could walk, you can catch a ride share, because the campus has grown quite large. But iterating on that feedback from our customers last year to make the experience better, we decided this year we wanted to give our customers full visibility into the expected travel times so that our customers could make a choice if they want to take that Uber or Lyft, they want to walk, or they want to catch a shuttle.
I should probably say at this point that reInvent is spread over 6 different venues here in Las Vegas, and that whilst you think about Vegas in terms of just a few properties that are down the strip, each one of the hotels here is like a mile square, right? So
Absolutely.
If you talk about walking from one hotel to another, you're talking about a 2-mile round trip to do that. So we have a transportation infrastructure to get our customers around for the different sites where the conference takes place.
Absolutely, and thank you for that point. So for us to calculate walking and ride share, we can calculate that from APIs that are available external to us, but the shuttle experience is tough. That's a physical domain problem. We have to know where our buses are, we have to know where they're heading, and we also have to know how long you're expected to wait in line. And if you've seen any of the lines at any of the venues,
does that mean you have like capacity also in that for the bus, like the shuttle?
It means we calculate where our shuttles are, how many we actually have en route, where they're headed to, when we think they're going to be available to you, and how long you expect to wait in that line.
So not how many people have filled the seats.
We have an idea of
Yeah,
that.
is that version 2 maybe?
That's a future-looking
Version 2?
backlog
Okay.
item, yes, correct. So what I want to focus on today, where Greengrass becomes relevant, is yes, we can track our shuttles, and yes, we can get that information, but the really difficult problem we had to face this year was, how long are you going to wait in line? What's that right experience? Do you want to wait in that line, or do you want to just get in an Uber? So to answer that problem, we brought in cameras. And so this year, as you can see in my visual here, we've got, every line has 2 cameras. There's a camera on the entrance to the line and a camera on the exit of the line. And using Greengrass technology on logic supply hardware powered by Intel, which you can see right here, we're using the logic supply ML350G-10. It's an Intel Core i5 CPU with 8 gig of RAM. And we're running the Greengrass core on this. And if I open it up a bit further,
Oh, you came prepared.
Yeah, look at that.
you can see it's a fanless, it's a fanless design with the motherboard. The Intel CPU is right there. It's a Core i5. We love this device because it works in high temp and wide temp environments as well.
So fanless, yeah.
Fanless, yes, 100%. We love the Raspberry Pi operating system, but this runs Ubuntu 16.04 LTS, so the things that you're
cool.
familiar with in your remote environment are here to you local.
Yeah.
So we've placed we have these devices in locations on our campus that read the cameras for the data as they're calculating both how many people are entering the line and how many people are exiting the line. And we use Greengrass to deploy Lambda functions written in Python to say, okay, what is the average count we've got at any given point in time? and what's the line rate.
You've got the overall system architecture here, so
do.
can we share the laptop so we can take a look at how the system is architected?
Oh
That's
yeah,
great.
let's look at this demo.
Perfect. So as you can see on the far right, that's the actual experience you get today from your mobile phone, from the official reInvent application.
Cool.
If you go into the transportation section, you can make a calculation to say, how long is my ride expected to be from point A to point B? And we calculate that information all the way at the front by looking at our inbound lines.
Yeah.
And we read the cameras on each line, 2 cameras per line with our Greengrass core running on Logic Supply hardware powered by Intel. We bring that information in locally. We determine the line count and the flow of the line,
Yeah.
and we publish that information back to our internal API gateway service that we've built.
Yeah.
And
yeah.
in the end, we bring that into a Lambda function where we do additional processing and make that available to the application.
Okay, well, you know what? We've got quite a few questions coming in on
absolutely.
the chat, so
Yeah.
I'm gonna let you guys field it. One of the ones here from Why the Heck Me? New to the concept of FreeRTOS, do you have a demo platform in mind that they can look at before designing their own?
Yeah, sure. So we've actually qualified FreeRTOS on a lot of development boards, so you can actually get started with, for example, an ESP rover kit. It's about $30 or so.
ESP32?
ESP32.
In fact, it's like you can get it on Amazon for $10.
Yeah.
And Amazon's this little lone retailer, by the way.
So there are actually 8 others that we've qualified, and you can get started on these development boards with FreeRTOS.
STM32, that's one.
STM32.
Okay, so you got
Nordic,
quite a few.
Nordic, TI, there's a bunch of them.
Yeah.
If you don't want to buy hardware, you can also get started on a Windows simulator.
Okay, so you can use the simulator. And I
Yeah.
think there's another gentleman here, or person who said, local ghost 0, would you recommend a few devices to play with Greengrass and FreeRTOS? So with Greengrass, recommending the devices there, you've touched on it already. Which one is it?
I think, so I won't give one particular. When you're
Sure.
selecting devices, you look at the operating system,
Yeah.
your processor architecture.
I think they mean just with like prototyping, developing, trying it out.
Raspberry Pi is always an
Raspberry Pi, there you
excellent
go.
selection. But let me be clear, this is less than $500 and is industrial.
Yeah?
So for $431 starting price, right? So
Oh.
start an EC2 with Greengrass.
Yeah.
Raspberry Pi in the local physical. Make your selection on operating system and processor type, and these devices remain under
and
$500.
the name of the device again?
That's a Logic Supply box. This is the ML35010.
Okay, and that's a question from someone
That's
called
very
Sam
popular.
Hadeen PC. So, we're going through the list here, but
Yeah.
sorry, I didn't mean to
Yeah, no.
derail you from your train of thought. Just one more here is, oh, wow. This is from Ultra 2 SE213 Fanatic. Oh, man. Is Greengrass used in Amazon Go?
Greengrass is being evaluated in Amazon Go.
I like that answer. Folks.
Can you tell me a little bit more about the machine learning model that's present on the device? How do you actually figure out how many people are in the frame? How do you do that?
This year we deferred analytics to our camera, and we actually don't process that at the edge for multiple reasons.
Okay.
One of which was we want to make sure we deliver the right experience and that this is not an environment for us to experiment in. We have that experiment in our labs. You should expect we'll grow into edge-based ML inference over time.
Okay.
But this year we've deferred back to our cameras for the sake of analytics, and we focused on getting the numbers right for flow count, line count, and accuracy.
Okay, so using AWS services to do the inference back in the cloud then?
We use AWS services to process the data and make the calculations, but the actual inference is deferred off to the camera this year.
Okay, cool.
So Steve, if we had ML inference with the launches this year, would you see that coming into play next year?
I think it's safe to say that's in our backlog, yes.
Awesome.
So if customers are looking for new things, they should log some feature requests, right?
We fundamentally believe in ML at the edge.
Okay. So you really like pushing ML to the edge.
Yeah, and we also believe in processing the camera off edge too.
Yeah. Okay. I think do we have any more questions coming up? No questions there, but look, you guys have talked about FreeRTOS, talked about Greengrass, and on the edge there. So why is this important to customers? Whether they be industrial or commercial, how does it actually help them where they're out in the field using these devices?
Yeah, so edge is, there's a pendulum swing between centralized computing and decentralized computing. It's happened for the history of computing. I was reading an article from 1971 where they're talking about decentralizing is the way to go, and then we actually put them all in mainframes after that, and then we went into data centers, PCs. So edge is sort of the next wave, right? There's going to be more devices that are producing a higher quality data. It's going to be more expensive to move that data all of that data to the cloud.
Is it like more expensive, or you You're saying in general?
It's going to be more expensive because there's more data being created.
Sure.
Bandwidth is actually increasing, but the amount of data generated is growing more than bandwidth is actually reducing. So there is a need for compute at the edge. It's only a matter of time. And then there's latency requirements. So sometimes you have to react. If you have a self-driving car, for example, you want to react
you
to
can't
things.
send that message to the cloud.
You can't wait, right? So there's also regulatory reasons sometimes where you actually have to process data close to where it's created without moving it off device.
Also the home, yeah, sorry.
And I would add to that too. I think from the customer perspective, the number one important thing for us at the edge with Greengrass is disconnected networks. I don't have to be on the same L2, L3 routing domain, the same network to get my camera data, be it whatever that is, right? APIs, analytic data, and more. I don't have to bring that back in-house on the same network, so I can be completely disconnected. As long as I have a route to the internet somehow, I can bring it back into AWS and then take my out-of-band management from the core.
Okay, so I think Ian touched on this as well. It's the fact that, and you and yourself, Prashant, is you're generating all this amount of data, and you want to massage it before you send it onto the cloud, so that's where you could use these edge devices.
It's a decision that every customer has to make. We had to make that decision as well. We do some local manipulation of the data, but we also consider in the event that there's a theft of the device, loss prevention, what does that look like? So we try to bring as much raw data back to AWS and do that calculation right there.
Both.
It is.
Okay, so it's both.
And it's a blast radius consideration. If you lost the device, how bad would you be? Is it faster to just ship that data to AWS and leave it there?
That's right.
Prashant, I've got a question for you. We've talked about quite a few different services here, ML inference at edge, Greengrass connectors, hardware security integration, as well as Greengrass and FreeRTOS. What are some of the ways that customers can get started with these services? If our stream viewers, for example, want to learn more about using AWS IoT, where should they go and how can they get started with some of these different service components?
So you have a choice to make at the beginning. You can either do software only through simulators, or you can buy hardware. If you want to buy hardware, we launched something called the Device Qualification Program that has a list of qualified devices for both Greengrass and Amazon FreeRTOS. Yep. The most popular one by far is the Raspberry Pi for Greengrass and ESP32 for FreeRTOS. You can go purchase that. We have a getting started guide for each of them that helps you get started with Greengrass if you install Linux on Raspberry Pi and get started there. Or you could go to FreeRTOS and just flash the device with the Amazon FreeRTOS hardware. It should take you a few hours to actually get started getting your Hello World running on these devices.
And actually, just to streamline that too, I think if we can bring the video back up, I think we want to call out as well that we went this road. We started with an EC2, then we went to the Raspberry Pi, and we realized the Raspberry Pi is a great device, but nothing feels and looks more like this. From a provisioning perspective, if we can bring the video back up, we want to call out the new Greengrass provisioning tools that were launched to GitHub on AWS Labs just the other day. If you haven't seen them, you can literally provision a core and its identity and its configuration in less than a matter of 10 seconds. So if that core feels like something you have to hug for a long time because it was difficult, your answer is in the links right here. And that package, we just confirmed today with the authors, is bringing hardware security integration support here very soon. So if you want to know what it takes to get on the secure TPM with Greengrass, you're looking at our example here. And you can, in just a few short days, we'll even have the provisioning for it in the GitHub AWS Labs section.
Okay, okay. And we actually have another question here from blah blah no. Why didn't you guys use Deep Lens?
Yes. So Deep Lens is a fantastic device. Ultimately, Deep Lens for us served as a reference development kit, a starting point to help us understand where to go. When we look at Deep Lens, number one, we have to have a secure element here. We don't have that support. And number two, there's an industrial component, right? That Deep Lens would have to be right there. I don't have to deploy my Greengrass core devices necessarily at the cameras. I don't want to do that, right? Loss, theft, fire issues. So for us, we looked at Deep Lens, we worked with it early. It's a great device, but we ultimately view it as a reference development kit and a starting point for how to figure it. So we went off edge, off the camera.
Play around with it. And
give us most flexibility, most options in terms of compute and OS.
Okay, okay.
There's a question on stream from ABOM TV about building Alexa-compatible devices, things like smart home infrastructure, like bulbs and locks. Genericizing the question a little bit, is it possible to build devices like that using AWS IoT? Is that a potential use case for these services?
Yeah, absolutely. So a lot of customers have actually tried using Amazon FreeRTOS with AVS or the Alexa Voice Services SDKs and putting them together on a device. And you can essentially talk to your light switch if you wanted to do that.
Or you can remote control your light bulbs that might have similar MCUs in them.
Exactly. So there are experiments like that customers have run. So we're building toolkits like this and seeing interesting use cases come out all the time.
Awesome, great.
Yeah, I mean-
We're pretty much out of time here, so we're going to have to wrap this segment up now, but I just want to thank our expert guest for joining us on twitch.tv/AWS today. Thank you,
guys.
Rudy, for co-hosting.
Thank you for being here too.
We'll be back really, really soon. We'll talk to you live from the AWS reInvent 2018 show in just a few minutes. Bye-bye.
Bye,
you.
Internet.
Thank you.